Good morning, everyone. Today I'm going to report to you about the formation and depletion of the ozone layer. So, let's start. Formation of the ozone layer. Ozone is formed in the atmosphere when energetic ultraviolet radiation dissociates molecules of oxygen, O2, into separate oxygen atoms. Ozone is thus continuously created and destroyed in the atmosphere by UV radiation coming from the sun. Here are the steps in the formation of the ozone layer. First, the ultraviolet radiation interacts with the CFC molecule, stripping off chlorine atom. Second, the chlorine atom strikes an O3 molecule, resulting in an O2 molecule and chlorine monoxide molecule. Third, a free atom of oxygen collides with chlorine monoxide. And the last, two O2 molecules are formed and the Cl atom is freed to destroy another O3 atom. Ultraviolet C is fully absorbed in the atmosphere by oxygen and ozone molecules. In this creation or destruction process, the amounts of ozone molecules created and destroyed are roughly equal, so that the total amount of the ozone in the atmosphere is nearly constant. However, reactions of ozone with other trace gases alter the ozone budget. These reactions are catalytic reactions. The chlorine atoms act as the catalyst, and each can break down tens of thousands of ozone molecules before being removed from the stratosphere. Depletion of the ozone layer. When CFCs reach the upper atmosphere, they are exposed to ultraviolet rays, which causes them to break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in the ozone and rips apart the ozone molecule. All consumer and most other aerosol products made or sold in the US now use propellants such as hydrocarbons and compressed gases like nitrous oxide that do not deplete the ozone layer. Aerosol spray cans produced in some other countries might still utilize CFCs, but they cannot be legally sold in the US. So we're done with our presentation about the formation and depletion of the ozone layer. So now we're going to play a video about our report.
Truly, life on Earth could not exist without light from the sun. But solar radiation contains harmful ultraviolet rays. Fortunately, some 30 to 40 kilometers up in the atmosphere, an ozone layer effectively stops most of these ultraviolet rays from reaching us. Solar radiation goes through complex processes which ultimately enable a livable environment around the Earth. Though a limited amount of ultraviolet rays from the sun are desirable, prolonged exposure is harmful to man and all life forms. But ultraviolet rays reaching the Earth are reduced through a series of reactions in the atmosphere. Oxygen is transformed into ozone and vice versa. Thus, a rich ozone layer absorbing ultraviolet rays is formed. But man-made chemicals called chlorofluorocarbons disturb the delicate ozone-oxygen balance. The CFCs react with ultraviolet rays and release chlorine. The chlorine reacts with ozone and destroys it in a chain reaction. Ultimately, there is less ozone to absorb ultraviolet rays. These ozone-depleting CFCs came to be known as miracle substances because they are stable and non-poisonous. They were first used as working fluids in refrigerators, then later in aerosol products like sprays, for foam products, and as solvents in paints and pesticides. CFC production is cheap and its storage easy. Naturally, they remained popular until the connection between CFCs and the destruction of the ozone layer became apparent. Some industries have begun using replacements like LPG instead of CFCs in aerosols. It has become fashionable to label products as ozone-friendly. Little is known about the impact of CFC replacements on the atmosphere. Mankind is looking for ways to protect the ozone layer so that excessive radiation does not impair life on Earth. Ozone depletion and the concurrent need to eliminate use of CFCs is the first environmental issue to catch global attention. Countries worldwide have signed the Montreal Protocol Treaty, which ensures phasing out of CFCs by the turn of the 20th century. Developing countries like India use limited amounts of CFCs and insist on international financial support to achieve the necessary changes towards ozone-friendly technology. The focus of the story of sunlight and ozone has been split up between science, vested industrial interests, and intergovernmental politics. It remains to be seen if mankind can overshadow them all.